Scientists made a terrible mistake about Venus. For decades, they believed it was paradise, a tropical world hidden beneath beautiful white clouds, warm oceans, humid jungles, maybe even life. They were so confident that when the Soviet Union launched their first probes, they installed sensors to detect water. They designed instruments to study swamps. They expected to find Earth's twin. What they found instead still disturbs scientists today. And the images they captured reveal something so wrong about this planet that 40 years later, we still can't fully explain it. This is that story. The first missions didn't land, they didn't even come close, and the reason why terrified everyone. In 1967, the Soviet probe Venera 4 entered the Venusian atmosphere. Engineers had calculated surface pressure around 20 times that of Earth, high but manageable. They built the probe to handle it. Venera 4 deployed its parachute and began drifting downward, temperature rising, pressure increasing, everything looked perfect. Then the signal vanished. At 27 kilometers above the surface, the probe stopped transmitting. It hadn't burned up, it hadn't malfunctioned. It had been crushed. The atmospheric pressure at that altitude already exceeded the probe's structural limits, and it was nowhere near the ground. The engineers checked their calculations. They ran the numbers again. The answer was terrifying. And what they discovered next would force them to completely reinvent spacecraft engineering. The pressure wasn't 20 atmospheres, it was closer to 90. Standing on the surface of Venus would feel like being crushed under 1 kilometer of ocean water. They tried again and again, each failure revealing something worse about Venus. Venera 5 and Venera 6 used smaller parachutes to fall faster. The logic was simple: descend quickly enough to reach the surface before the pressure kills you. Both probes imploded at 11 kilometers altitude. Venus was rejecting every attempt to reach its surface. The engineers realized they needed something completely different. They stopped building spacecraft. They started building submarines. Venera 7 launched in 1970 with a revolutionary design, forged titanium pressure vessel, built to withstand 180 atmospheres, double the expected load. They stripped out almost every scientific instrument to save weight for armor. No windows, no solar panels, just a battery, a thermometer, and a radio. The probe entered the atmosphere. The parachute cords melted during descent. Venera 7 didn't float gently to the surface. It fell hard. Impact speed was 17 meters per second. In mission control, the telemetry flatlined instantly. Another failure, another dead probe. Or so they thought. Weeks later, an astronomer reviewed the raw radio recordings. He noticed something buried in the static, a pattern, a rhythm. The probe hadn't died on impact. It had toppled onto its side, pointing its antenna away from Earth. But it was still alive, still transmitting, still whispering. By processing the noise, they recovered 23 minutes of data from the surface of Venus. The first transmission ever received from the surface of another planet. The temperature reading was 475 degrees Celsius. Hot enough to melt lead, hot enough to destroy any camera in seconds. But the Soviets were about to attempt something that everyone said was impossible. Now, if you're still with me, what comes next is where this story gets incredible. Because the Soviets were about to see something no human had ever seen before. But surviving was only half the problem. Now they wanted to see, and seeing on Venus was supposed to be impossible. Standard television cameras used glass lenses and fragile vacuum tubes. Glass would shatter under 90 atmospheres. Electronics would fry instantly at 475 degrees. So Soviet engineers invented something entirely new: a telephotometer. Instead of capturing a complete image, this device used a tiny rotating mirror. It measured the brightness of a single point, then rotated slightly, measured the next point, dot by dot, line by line. Building one image took over 30 minutes. If the probe died before finishing, the picture would be incomplete forever. But slow meant simple, and simple meant survivable. They faced another problem: darkness. Scientists calculated that almost no sunlight could penetrate 90 atmospheres of carbon dioxide. The surface would be locked in permanent blackness. Engineers installed powerful floodlights on the lander. They expected to photograph a world of pure darkness. On October 22, 1975, Venera 9 touched down on Venus. The lens cap fired off, the camera began scanning, and the floodlights were completely unnecessary. The surface of Venus was not dark. Light levels matched a cloudy afternoon in Moscow. The thick atmosphere didn't block sunlight, it scattered it, creating a soft, diffuse orange glow that illuminated everything evenly. Scientists had been wrong again. As the image built up line by line on Earth, another surprise emerged. They had expected a smooth, sandy desert. Dense atmosphere should create powerful winds that erode everything to dust. The image showed the opposite. Sharp, angular rocks everywhere, jagged edges, broken slabs, no erosion at all. The surface was geologically young. Something had shattered these rocks recently, and the winds were almost non-existent. But here's what made that disturbing. Wind speed measured 0.5 meter per second. On Earth, you wouldn't feel that, but Venus's atmosphere is 60 times denser. Even slow-moving air pushes with real force. Those rocks should have been worn smooth centuries ago. They weren't. 3 days later, Venera 10 landed 2,000 kilometers away, and what it saw proved Venus was hiding more than anyone imagined. Flat slabs of ancient basalt, dried lava flows stretching to the horizon. Venus wasn't uniform, it had distinct geological regions: mountains, plains, young terrain, and old terrain. The planet was far more active than anyone had believed. But everything I've shown you so far is just the beginning. Because in 1982, the Soviets captured something that changed our understanding of Venus forever. Venera 13 landed and survived for a record 127 minutes. This time, the camera could see in color. The telephotometer scanned 3 times using red, green, and blue filters. Scientists combined the data into a composite image. The result shocked everyone. The entire world was orange. The rocks were orange, the sky was orange, the horizon was orange, every direction nothing but deep, suffocating amber light. This wasn't a malfunction, it was physics. Venus's atmosphere absorbs all blue and green light before it reaches the surface. Only red and orange wavelengths survive. A human standing on Venus would see the world in permanent sepia tone. Your eyes couldn't adjust, your brain couldn't correct it. Because there is no white light anywhere on that surface. Venera 13 also carried a microphone. It recorded the first sounds ever captured on another planet. A low, constant rumble, dense atmosphere flowing across the lander, a deep drone even at minimal wind speed. Then a sharp crack, the drill firing, then grinding, metal cutting through solid basalt. Venus wasn't just hot and bright. It was loud. But the cameras captured something else, something that still confuses scientists today. In the images, the horizon is clearly visible. The atmosphere at ground level is surprisingly clear, no dust, no fog. But above, in the upper atmosphere, something strange is happening. The clouds of Venus don't move like normal weather. They whip around the planet at insane speeds. The entire atmosphere completes a full rotation in just 4 Earth days. But here's what makes that disturbing. The planet itself rotates incredibly slowly. 1 day on Venus takes longer than 1 year on Venus. Read that again. The sunrise to sunrise cycle is longer than the entire journey around the sun. The atmosphere should follow the planet. It doesn't. It moves 60 times faster than the surface beneath it. And at the poles, this creates something that looks almost artificial. A massive spiral vortex, sometimes shaped like a single eye, sometimes splitting into two eyes that rotate around each other. On a planet with no oceans, no seasons, and no weather system as we understand it, this structure shouldn't exist. But it does, and no one can fully explain why. But here's where the mystery deepens. Everything I've told you so far, scientists can partially explain. What comes next, they can't. Venera 14 landed 4 days after Venera 13 with identical objectives: photograph the surface, analyze the soil, test ground hardness. The lander carried a spring-loaded arm designed to strike the ground and measure compression, a simple test. The lens cap ejected perfectly during landing. But it didn't bounce away. It landed directly beneath the testing arm. Moments later, the arm deployed automatically. It swung down and struck the object underneath. The data transmitted to Earth indicated the surface of Venus was extremely hard, zero compressibility. Technically accurate. The arm was measuring the titanium lens cap it had carried from Earth. The actual Venusian surface lay centimeters away, untouched, untested. Millions of kilometers of travel, years of engineering, the most hostile environment ever explored. Defeated by a lens cap. The photograph confirming this failure remains one of the most famous images in space exploration history. But that wasn't the real tragedy. After 1982, the Soviet program shifted to orbital radar mapping. Surface missions ended. Then the Soviet Union collapsed. The Venus program died. The data sat on magnetic tapes that slowly degraded for decades. Think about that for a second. We've sent robots to Mars that stream 4K video daily. We've photographed Pluto from billions of kilometers away. We've landed on asteroids, on comets, on moons of distant planets. But Venus, the planet closest to Earth. Our last photograph is from 1982. Those orange-tinted panoramas from dying Soviet probes are the only direct images we have. Everything else is radar, computer renders, artist imagination. We explored hell for 127 minutes. Then we stopped. And the questions those images raised still have no answers. Why is the surface so young? What keeps breaking those rocks? Why does the atmosphere spin 60 times faster than the planet beneath it? What creates those impossible storm patterns at the poles? Something is seriously wrong with Venus. And Venus is not waiting for us. Venus doesn't care if we return or not. But we should care. Because the answer to what went wrong on Venus might be the answer to what could go wrong on Earth. Our only window into that world closed 40 years ago. And it's still closed. What do you think we'll find when we finally open it again? Tell me in the comments. And if this changed how you see our closest neighbor, hit subscribe right now. Because next week, I'm covering something even stranger. A discovery in our own solar system that NASA still refuses to fully explain. Trust me, you don't want to miss it. See you there.